welcome back. I just had my a peanut butter cup, and a Kit Kat bar, and now I'm ready to rock. So another type of reaction that I want to talk about is precipitation reaction. So we're going to use the solubility rules that we just talked about, and we're going to apply these to a double displacement reaction. So let's take a look at what we're talking about. Okay, in a precipitation reaction, it's really a double displacement. And once again, I've done a few examples. The cation of this reacts with the anion of that, and I like to draw it this way: the cation of this reacts with the anion of that. And so what can happen is that one of your products becomes a solid. Okay, and in a rare occasion, both of them become a solid. But in general, usually what happens is one of these species will become a solid. Okay, and so that's what a double displacement reaction is with a precipitation, which means a solid is formed. Okay, and so if I had the video here, what you would see is that you could take two liquid compounds, and then if you added them together, a solid would come out. Solid. And so that's a classic example of a precipitation reaction when you take two liquids, usually clear, and you get a solid after you mix them. Okay, so we can think of a double displacement reaction as just as a double displacement, and then if a solid forms, we call that a precipitation reaction. So let's do a few examples. So the first thing I'll do is the following. These three examples. And in all double displacement reactions, you just take the cation of one and react with the anion in the anion of the next one. And then you take the cation of the second and react with the anion of the first. The one thing that you do just have to be cautious about is what is the charge of these species. And so if we take a look, this charge on the lead is +2. This charge on the nitrate is -1. The charge on this potassium here is +1. And then this charge on the CrO4 is going to be -1. So when we do the precipitation reaction, we're going to have lead 2+ reacting with this CrO4. So if we crisscross, you'll get CrO4 2+, and then K is +1, then I plus KNO3. Now then, this is where you would look up the, This is where you would look up the solubilities, and you'll see that potassium compounds are always soluble, so this is aqueous. And then if you take a look at CrO4, you'll find that any lead compounds especially are going to be insoluble. Okay, and so if we wanted to balance this, I'm going to just erase this part here so that we can balance it. What we would do is, is we would put a 2 in front of this potassium compound, and then we would put a 2 over here. And I think we're all set. So next example is we have copper sulfate reacting with barium hydroxide. So the first thing I'm going to do is the copper is going to go with the OH, and the Ba is going to go with the SO4. And so the first thing I'm going to do is I'm going to notice, I'll write the charges again. This is going to be +2, -2, +2, -1. So when we have this reaction, the first thing we're going to see is the copper is going to form CuOH2+, and then BaSO4. Now we go to our solubility chart, and we see that under hydroxide, they're insoluble except for sodium, potassium, and barium. And so copper hydroxide is going to be insoluble. And then we would go to sulfate compounds. all sulfate salts are soluble except, and barium is one of the exceptions. So this is an example where you form two solids. Okay, and I'm going to just erase the charge part, and I'm going to just check to see if it's balanced. And the answer is 1 copper, 1 copper. Yes, this is balanced. Okay. The next example is going to be the calcium. Is calcium chloride reacting with sodium carbonate. So calcium is going to react with the carbonate, and the sodium is going to go with the chloride. And so what we form is Ca. Actually, let me take a step back. The first thing we do is we're going to get the charge. This is a +2, and this is a -1. This is a +1, and that's a -2. And so what you see now is the following. You're going to make CaCO3 plus NaCl. So you make sure that the +1 and the -1 come together. And so at this point, we take a look at our solubility chart, and we look under carbonates, and it says all carbonates are insoluble except for sodium, potassium, and the ammonium ion. And that's not in this case, so that's a solid, and sodium chloride is aqueous. And so the last thing to do would be just to, I'm going to erase this part, is to balance it. And so I take a look, and I notice that I have 2 sodiums on the reactant side, so I'd have 2 sodiums on the product side. And so those are the products of the following reactions. So more examples are coming. So why don't we do the following? Take 30 seconds, or just pause it, and then see if you can do the you try. So right now, pause and try. Welcome back. I'm going to do the following here. I'm going to answer this. So the first thing I'm going to do is just write the reactants here. Aqueous plus KOH, aqueous. And then I'm going to do my double displacement. So the first thing I'm going to do is the iron's going to react with the OH, and the potassium is going to react with the nitrate. And so then I always write the charge. This is going to be +3, -1. Potassium is +1, and this is -1. And so what do I get in the end? The iron is going to react with the OH, and so the iron is +3, the OH minus is -1, so this is going to be FeOH3 plus KNO3. And now we look at the solubility chart, and the hydroxides are insoluble, and that's going to be insoluble. And then KNO3, potassium salts are always soluble. So the answer to this is going to be D. Okay, and if you wanted to, just for completeness sakes, I'm going to erase this part here. I'm trying not to erase my lettering. I did, but I'll write it back. And I'm just going to balance it just because I like the practice. Okay, so let's get that K back. Okay, so I've got 1 iron, but notice I have 3 nitrates here, so I'm going to put a 3 right there, and I think that is good to go. So that's an example of a double displacement precipitation reaction. Okay, now what we can do, we can also then do what I showed before is going to be, let's do the net ionic. And so what you end up doing is doing what we just did, and then breaking it down into its a little bit into its ions. So let me do an example. Write the net ionic equation for the reaction of lead nitrate and potassium chromate. So the first thing we end up doing is going to be the following. We're going to write lead 2, so Pb parentheses NO3 2 aqueous plus K CrO4. Okay, and so we are going to do the double displacement. So the first thing I'm going to do is just write the charges. It gets repetitive, but I like doing it this way. +1 - 1. So then now what I do is the lead's going to go with the chromate, and the potassium is going to go with the nitrate. And so the charge on the potassium is the charge on the lead is +2. So this is going to be Pb parentheses CrO4 2 plus KNO3. Lead chromate compounds are insoluble, and so this is going to be a solid. Didn't mean to do that. This is going to be 2 solid. And so if we wanted to balance this, I'm going to first balance this. I'm going to erase just my charge part. And I'm going to come over here and erase this. Oh, I got rid of that. Let me do this. Okay, so notice what you have is you have 2 nitrates on the reactant side. So I'm going to put a 2 here and a 2 here. And so that is, and this is aqueous. And so that's my molecular equation, or my overall equation. Now what we end up doing is we're going to take all of the aqueous salts and break them into its components. And so this is going to be Pb 2 plus 2NO3 minus 2K plus 2CrO4 minus. So what you do is you just break it into its components. This is aqueous, this is aqueous, this is aqueous, and this is aqueous. Now, when we have a solid, we just leave it alone. So the lead chromate is just going to be left alone, but the potassium nitrate can be broken into its parts. Aqueous, aqueous. So that is the complete ionic equation. And what I'm going to do now is I'm going to cross out ions that are the same on both sides, and that also includes the same number. So I have 2 nitrates here. I have 2 nitrates there. I have 2 potassiums here. I have 2 potassiums there. And so that's all I can do. And so my net ionic equation is going to be Pb2 plus aqueous plus 2CrO4 2 minus aqueous goes to PbCrO4 2 solid. So that's an example of a net ionic. And I know that we're going to do more examples of that. So up next, we're going to finish things off by talking about gas-forming reactions. So I'm going to stop here on this section and then end up talking about gas-forming reactions. I'll be back shortly.